When you go to Excel, you will see a menu option called Data Analysis, in which you can find t-test paired two sample for means, t-test two sample assuming equal variance, and t-test two sample assuming unequal variance. In this tutorial, I'm going to explain the concepts and examples for the first two, and namely that I'm going to skip the third one. The reason being, I would like to keep this tutorial more compact. This will make easier for some of you might just got started to learn about t-test, and I might make another tutorial to explain the assuming equal variance versus assuming unequal variance. But this is not the focus of this tutorial. What is t-test for? Basically, t-test is used to compare if two means are significantly different. Let's look at the first scenario. I call it as ice cream sales scenario. Let's look at the t-test paired two sample for means. So this is a hypothetical data set, namely I randomly generated this data set for the purpose of this tutorial. Namely, this is not a real data set. In this data set, we measure the ice cream sale from 5 stores in 2 different months, August versus November. So there are 2 columns of data here. We can calculate the sample mean for the first column, which is 25, and we can calculate the mean for the second column, which is 12. The t-test here is try to see that whether these two means are significantly different or not. Here, the first column and the second column are 2 samples, and they are a pair. What does it mean? Let's look at closely. We look at the 2 numbers in the first row, which are, these 2 numbers are 30 versus 20. So these 2 numbers, these 2 ice cream sales number are from the same store 1, namely. So that's why we call it is a pair. It's a pair of data. In terms of theoretical framework, the x variable here is months, so namely August versus November. The y variable here is ice cream sales. So this is the example for paired 2 sample. Let's look at 2 sample. This is another hypothetical data set, namely I randomly generate this data set. And so this is not a real data set, but again, let's look at this data set more closely. So again, this has 2 columns of data. So basic idea is that we try to see that with the 61 and 62, the ice cream sales, they are different or not. So we got this data from 10 different stores. And we can calculate the mean for the first column, namely the data, the numbers from 61, the mean is 20. And similarly, we can calculate the mean for all 5 stores from 62, so the mean is 11. And the t-test here is try to see that whether these 2 means are significantly different or not. Here, there's 1 sample from 61, 1 sample from 62, and these 2 samples are independent. What does it mean? It means that, for instance, let's look at the numbers more closely, the 25 versus 23. These 2 numbers are from 2 different stores. So this is different from the left-hand side, which those 2 numbers are from the same store. Let's look at the theoretical framework. The x variable is different from the left-hand side. The x here is 60s, 61 versus 62. The dependent measure is the same, ice cream sales. And I would like to make a note here is that a 2 sample t-test is also called as an independent samples t-test. So namely that 2 samples are independent here. So this is the first scenario. I call it as ice cream sale. Let's look at another scenario to better understand the differences between these 2 types of t-test. I call it as a brain additive scenario. So let's look at the t-test pair 2 sample for means. Again, this is a hypothetical data set, namely I randomly generate this data set for the purpose of this tutorial. That means that it's not a real data set. So basic idea is that here we measure attitude toward brain A and brain B from a group of 5 people. And we can calculate the mean for the first column, namely the attitude toward brain A and the attitude toward brain B. So the basic idea is that each person will answer or indicate their attitude toward brain A, and also they will indicate the attitude toward brain B on a 7-point scale. So these two samples, namely sample for brain A and sample for brain B, these two samples are a pair. So namely that the numbers of 5 and 2, these two numbers are from the same person, person 1. In terms of theoretical framework, the X variable here is a brain, namely brain A plus brain B, and the Y measure here is brain attitude. Now let's look at the t-test for two sample. This is another hypothetical data set, namely I randomly generate this data set. So this is not a real data set. Okay, let's look at it more closely. So basic idea is that we have 10 people in this data set and 5 people from 61 and 5 people from 62. So this is different from the left-hand side example, which only have 5 people. In contrast, there are 10 people in the right-hand side. And we can calculate the mean for the first column, the mean is 6, and the mean for the second column, the mean is 5. And the t-test is try to test that whether these two means are significantly different or not. These two samples are independent. It means that, for instance, the number of 6 and 5, they are from two different persons, person 6 and person 11. In contrast, on the left-hand side, the 5 and 2 are from the same person. In terms of theoretical framework, the X variable here is 60. So namely 61 per 62. The dependent measure is brain attitude. Again, a two-sample t-test is also called as an independent samples t-test, since that the sample 1 and sample 2, they are independent. So this is the second scenario. I call it as a brain attitudes scenario. Now let's move to Excel, and I'm going to explain how you can do that in Excel. On the left-hand side is the t-test pair two sample. On the right-hand side is t-test two sample. I also wrote out the two-tailed hypothesis. For the non-hypothesis, for the left-hand side example, is that August and November do not differ in terms of ice cream sales. Alternative is that they do differ. For the right-hand side example, the non-hypothesis is that 61 and 62 do not differ. Alternative hypothesis is that they do differ. Okay, we can then click the data analysis, and we're going to first look at the pair to sample. Click OK, and OK. Then we can select this, and then the second one we select this. And then click it, and we tell that click this, that there's a label. So namely that we have labels of August and November. And we then can just leave the alpha 0.05 as default, and we're going to save the result as a new worksheet. So click just OK. So this is the result. Basic idea is that we have mean 25 and 12, and we're going to see that whether these two means are significantly different or not. So that means that we're going to look at the p-value. Yes, we'll look at the two-tailed, since that we wrote our hypothesis as two-tailed format. So let's look at the p-value. The p-value is 0.06, which is greater than 0.05. That means that we fail to reject the non-hypothesis. So again, so that means that we failed to reject the non-hypothesis. That means that we cannot reject the non-hypothesis. Okay, so now let's look at the two-sample example. Okay, one thing I forgot to mention is that, okay, you might have question, why this is brain A? Can it brain B? Yes, it can brain B as well. The whole point here is that I try to emphasize that we are compared 61 and 62, and the brain is not the focus in this example. So we do not want to create another variation in terms of brains. So here I just keep the brain as the same. So it doesn't matter whether brain A or brain B or even brain C. So we just try to keep the brain as consistent here. So to make sure that we just focus on 61 versus 62, we do not want to have another variable here. Okay, let's click the data analysis again, and we're going to two sample assuming equal variance. Click OK, and we are going to select the data example here, the data here, and then the data here. Okay, and we also tell that we have label 61 versus 62. Again, it will say the result in a new worksheet. So let's click OK. So this is the output here. So these are the two means. And we're going to look at the p-value, so which is the two-tail. We're going to focus on two-tail here. And so the p-value, which is the 0.14, so which is greater than 0.05. So that means that we fail to reject the null hypothesis. That means that we cannot reject the null hypothesis. Okay, so this is the first scenario example, namely the ice cream example. Okay, now let's look at another example, namely the brain attitudes example. One note is that I'm not very sure that whether you need to write ed for the two-tail, add this ed, these two letters, but that's the way I write that. I'm not sure. Anyway, this is not the focus of this tutorial. Okay, so the null hypothesis here is that for the left-hand side, namely the pair 2 sample, the hypothesis that brain A and brain B do not differ in terms of brain attitude, and alternative hypothesis that brain A and brain B do differ. In contrast, for the right-hand side, namely the two sample example, is 61 and 62 do not differ, and alternative is that they do differ. So now let's go to data analysis menu to see how we can do that. So we can click the pair to sample first, and we're going to select this, and going to select this. We tell that there's a label, namely brain A and brain B. We have a label here, and we're going to save the result as a new worksheet. So click OK. So this is the output. So the p-value here, okay, we're going to focus on the two-tail. So here, the two-tail, they do not have ed here, yes. But when I roll, so here I roll it as with ed. I'm not sure which one is correct, or maybe both of them correct. I'm not sure. Anyway, let's look at the result here. Yes, so the result here, the p-value is 0.02, which is smaller than 0.05. That means that we are going to reject the null hypothesis here. That means that these two means are significantly different. Okay, so this is the pair 2 sample example. Now let's go to the two sample, namely the independent samples t-test. So let's go back to data analysis again. We're going to click the two sample assume equal variance. So we're going to, select these cells and then these cells. And the label we check here, so that means that we have 61 and 62, these two labels in our selection. Go save the result. So this is the output. So enlarge, able to see it more clearly. So these are the two means. And we're going to focus on the p-value for two-tail. So the p-value here is 0.105, which is greater than 0.05. That means that we fail to reject. That means that we cannot reject the null hypothesis. Okay, I think that's it. I explained the pairs 2 sample and 2 sample t-test in the context of Excel. So if you have any questions, feel free to comment down below, and I will do my best to answer the questions you might have. Okay, thank you for watching.